Welcome to our lesson of science. Last week, we looked at simple machines and frictions, and we looked at other subtopics. But remember, we are still continuing with the same topic. So tonight, we would like to look at the classes of simple machines. And the classes of simple machines are well listed, or are well written down here. As you can see, we have pulleys, we have wheel and axle, we have wedges, we have screws, inclined planes, and levers. So these are the classes of simple machines. These are not examples of simple machines, but they are classes of simple machines. So out of this, we picked levers. And the definition is well written on the whiteboard. A lever is a stiff rod that turns on a fixed point called pivot or fulcrum. What's a lever, Simon? Very good, Simon. A lever is a stiff rod that turns on a fixed point called fulcrum or pivot. So another word to mean fulcrum is pivot. And what's pivot? Pivot is a turning point of a machine. Very simple, just like ABC. So these are parts of a lever. The parts of the lever, there are basically three. The first part of a lever is the load. And the second is the effort. And then we have the fulcrum or pivot. So what's the load? The load is the weight of the body to be lifted. It's just like in case we have a bag of 20 kilograms of flour or of maize flour and you would want to lift it, you use the effort, and the 20 kgs of the maize flour is the load, because that is the weight that you have to overcome using what? The effort. Therefore, we have the load as a part of a lever, which is the weight of the body to be lifted. As simple as that. Then we have the effort. What is the effort? The effort is a force which is exerted on a machine to overcome the load. The force or the energy you use to lift up the load is what you call the effort. The force exerted, put in. What does the word exerted mean? Injected or put in order to lift up the weight. Then we have the fulcrum. In other words, mean the fulcrum is pivot. So tomorrow an examiner may decide to bring this or may choose to bring pivot and leave out fulcrum. Of course, the definition remains the same. It's a turning point of a machine. As simple as that. What's pivot? Is a turning point of a machine. What's fulcrum? Is a turning point of a machine. So this is an illustration. This illustration shows the three parts of a lever. Whereby here we have a simple machine. What example of a simple machine is this? A seesaw. So I've used my seesaw to identify or to locate the three parts of a lever. And here it is, well drawn. So here, when you look at on my left, you realize that we have the load. Then on my right, we have the effort. And then in the middle of this machine, we have the fulcrum. Remember we said this is where a machine turns. It's a turning point of a machine. The pivot, if not the fulcrum. You get it? So it says that the fulcrum must be in the middle because it is a turning point of a machine. So these are the three parts of a lever. The first one is the load, which is the weight, to be overcome by the effort, which is on my right. Then we have the fulcrum in the middle. So basically, these are the parts of a lever, and these are the locations where you can actually allocate them. So we have definitions of these parts of a lever. But before we define these parts of a lever, let's look at the distance between the fulcrum and the load. The distance between the fulcrum and the load is called load arm. The load arm. the distance between the turning or from the turning point of a machine to the load is called load arm, is the distance. Then the distance between the fulcrum and the effort is called effort arm. As simple as this. So there's no need of failing these things. An examiner may bring a question, what's load arm? Please, what you have to say is, load arm is the distance between the fulcrum and the load. What is effort arm? Very simple, like ABC. Effort arm is the distance between the fulcrum and the effort. So, students or pupils, this is what we have. These are the parts of a lever. So we have the definitions of the parts of a lever. One, we began by actually with this, the load arm. What's the load arm? It's the distance between the fulcrum and the load. That's that. Any question? Alex? Very good. Alex asking, what's effort arm? Effort arm is the distance between the fulcrum and the effort. This is the effort arm. Okay? Are we together? Yes. So, pupils, you will have to allow me clean up this part here, such that I may write something here. We have the second part, which is the load arm. The load arm, we have what you call an effort arm. The effort arm is the distance between the fulcrum and the effort. That's that. So this is the definition of the effort arm. Is the distance between the fulcrum and the effort. So let's go ahead and look at other things. Since actually we've actually known this, let's look at the classes of levers. The classes of levers. Basically, when you're looking at the classes of levers, there are only 3 classes of levers. And these include, we shall have the first class lever, we shall have the second class lever, and lastly, the third class lever. So these are the classes of levers that are taught in 7. Even when you go to senior 1, we have this. So we have the first class lever, the second class lever, and then the third class lever. So these are the classes of levers which are taught. Then we actually want to continue, or we would like to go ahead and look at the first class lever. The first class lever. The first class lever So this is actually a definition of the first class lever. We said this is a class of lever where the fulcrum is positioned in between the load and the effort, where the fulcrum is found in between the load and the effort. So this is actually the meaning of the first class lever. So in an illustration, we are going to have one diagram here whereby we are going to have the fulcrum or pivot position in between the load and the effort using another example of a simple machine, leave alone this one here. So here, I'm going to have a diagram of a crowbar. So here, we are going to have the load, which is the weight of the body to be lifted. Then on this side, we are going to have the effort, which is actually the force that is put or that is exerted in a machine to overcome the load. Then in the middle, we shall definitely have what you call the fulcrum, which is actually a turning point of the machine. This is where this machine turns. This is actually the point. So I've used this simple machine to actually locate the position of the load, effort, and the fulcrum. And what kind of a simple machine is this? That is actually what you call a crowbar. So if I do not want to use such or this, actually I can actually draw here human beings. I can put here, draw here, a small girl, here a very big man. Then I actually tell the big man, or I actually tell the girl to overcome the load, which is actually the big man. And actually, this machine shall actually turn at that point. So we say this is actually the position of the fulcrum, and this is an example of a simple machine that we actually use, which is called a crowbar. So, without much ado, we would also want to look at the examples of the first class lever. What kind of machines do we find, or what kind of machines are grouped in that class of a lever? So one look at examples of machines, under the first class lever. So here, we shall actually have what we call scissors. We shall have what we call lid opener. We shall have scales or weighing scales. Not forgetting what we call water pump. We shall have pliers. We shall have pincers. Not forgetting claw hammer. So basically, these are the examples of simple machines. Those are simple machines that are grouped, or that are found, or that are grouped in this class of in this class of levers. So we shall actually have here scissors, a lid opener, scales, water pump, pliers, pincers, and then we have what we call claw hammer. So these are examples of simple machines. They are not classes of simple machines. So those are the simple machines which actually we can actually find in that class of lever. So leaving that apart, let's also look at the second class lever. We are going to have here what we call a second class lever. So we shall say this is a class of a lever where the load is positioned between the fulcrum. If not, I can actually use the word pivot and the effort. So this is the definition of the second class lever. It's a class of a lever, or is a class of levers where the load is positioned in between the pivot and the effort. So I'm going to have an illustration here, of course, to show the position of the load. So I'm actually going to use a diagram of the crowbar steel. I'm going to use this very crowbar. So here, I shall have my load, and then this is a turning point of a machine which is known as a fulcrum, and then the force which is called the effort. So we use the same simple machine, which is the crowbar. I will use it here to actually identify the position of the load, effort, and fulcrum. But remember, in the definition, we said second class lever is a class of levers where the load is positioned in between the pivot and the fulcrum. So this is the load, and the load is in between the fulcrum and the effort. So we find out the load in the middle of these two parts of a lever. So here at the extreme end, we shall actually have the fulcrum, and the other extreme end, we shall actually have what you call the effort. Then the middle, the load. As simple as this. So you allow me to wrap up here. And give you examples of machines under the second class lever. So we shall actually have these examples of machines under second class lever. So in this one, we shall have the following simple machines. One, we shall have the wheelbarrow. The wheelbarrow. We shall also have what you call the bottle opener. We shall have what you call a bottle opener. And not forgetting what we call the nut cracker. And then we shall have what we call human food. So basically, these are the examples of machines under what you call second class lever. We have the wheelbarrow, we have the bottle opener, the nut cracker, and then the human food. There's a difference between bottle opener and a lid opener. These are two different things. How are they different? Just because the bottle opener has got its load in between the load and the effort, whereas the lid opener, you can find it is load at the extreme end, then the fulcrum in the middle. So, of course, these are the examples of simple machines under that class of lever. So let's look at the third class lever. So in this class of lever, or levers, Here you're going to find, of course, the effort in between the fulcrum and then the load. So we shall say, this is a class of a lever. This is a class of levers where the effort is positioned in between the load and fulcrum. If not, I can use the word pivot. As simple as this. This is a class of levers where the effort is positioned in between the load and the pivot. That's all. So we shall also now, we shall look at the examples of machines. Examples of machines under third class lever. Under third class lever. Here we shall actually have what we call the human arm. Then you have what we call a fishing rod. I don't mean the other rod, but I mean a bar of a metal. Then I shall also have here what we call sugar tongs. We shall also have there what we call sugar tongs. Not forgetting what we call a spade. If not, we can also have something here which is known as shovel. So basically, those are the examples of machines under what we call the third class levers. We have the human arm, fishing rod, sugar tongs, and then spade or shovel. Now there's a difference between human arm and then the human foot. The human foot is under the second class levers, whereas the human arm is under third class lever. Now the difference is, with the human foot, you can actually find the load in between the fulcrum and the effort. But on a human arm, you will find the effort in between the fulcrum and the load. So that's the difference. So actually tomorrow when an examiner happens to bring for you a paper and ask you to give a difference between human arm and human foot, please, that's what you're supposed to say. And now, we would want also to look at the advantages of using first class levers. What is the advantage of using the first class lever, or what are the advantages? So we have one advantage. The advantage is the effort arm is longer compared to the load arm. So that's the advantage of using the first class levers. The effort arm is longer compared to the load arm. Or you can say the load arm is shorter compared to the effort arm. So in that way, or in this way, you realize that a human being shall use less or what you call lesser effort to overcome the load. So here, someone uses less effort to overcome the load just because the effort arm is longer as compared to the load arm. That's that. Leaving that apart, we also have something to look at. The advantage of using second class lever. The advantage of using second class lever. The advantage is lesser effort is used to overcome the load. So that is the advantage of using second class levers. So with that, my dear pupils, I would like to end here, and we shall actually meet next time. So my name is Chakatongole Atanas. My number is in case of any inquiries. Thank you.